Adjacent angles first. Two angles that are adjacent. Usually when I hear the word adjacent, I think of the word next to, I think of the phrase next to. They're next to each other. That's great, but we got to also make sure they follow a couple rules. But look at all these angles up here. They're next to each other, but they're not all adjacent. So what makes them adjacent? They have to have a common side, a common ray in common. Right? They have to have a common ray and no interior points in common. I'll show you what I mean here in a second. So everyone look at angle X and angle Y in part A. Are they, do they share a common ray? Yeah, everyone sees the common ray they have. And do they have a common vertex? Do they share? Yep, common vertex, common ray. Now, what's this mean by no interior points in common? Ready? Everyone put a point inside angle X for me. Just put a rando point inside angle X. Is that point also in Y that you put there? No. Can you put a point that's in both at the same time? No. So that means they have no points, interior points in common, where you cannot put a point anywhere where it's in both angles at the same time. Okay? So these two are adjacent. They share a vertex, they share a side, and no interior points in common. Hey, what do you think about B? Let's talk about B. You think those two, X and Y, are adjacent or not?
No.
No? Why not?
They don't share a vertex.
Okay, we could stop there. I don't care if everything else is fine. They don't share a vertex. They're not adjacent to each other. Perfect. Okay, now I got to do a little explaining here. All right. Angle Y is this one right here. Okay, angle Y is that angle. Angle X is the full angle here. This is angle X, everybody, the full angle. That's why I tried to draw that huge arc mark there. So everyone see what we're talking about? There's angle X, and here's angle Y. What do you think?
No.
They have a common vertex.
If you put a point.
Settle down. They have a common vertex. They have a common ray. What's the problem? All right, now you can go.
If you put a point in angle Y, there's also an angle X.
Watch, ready? That's an X, isn't it? Is it also in Y? Yeah, that can't happen. They can't have points in common. So that's why that one does not work. It's not adjacent. Questions? So everyone all good? Adjacent angles? All right, perfect. Now let's, I'll speed through this a little bit. Not too fast, but complementary. You guys have heard of that? Okay, here's one thing I got to harp on though. Everyone thinks complementary, add to 90, add to 90. You are correct. But here's the catch. Only two angles. It's only two angles that add to 90. Well, Mr. Carlino, what if there's three angles that add to 90? You know what we call three angles that add to 90? Three angles that add to 90. Okay, complementary is specifically reserved for two angles. So real quick, here's the elementary version of complementary angles. What maybe my daughter would do in second grade. 50 degrees. And doesn't even look good. 40 degrees. That's probably what you're used to. Those two are complementary, right? Great. That's not what I'm impressed by. Now we got to take it to the honors level. Here are two complementary angles. How do I know they're complementary? I don't see 90 anywhere. I don't see degrees to add up. Matt?
There's the signs for right angle.
Thank you. Right angles add to 90, right? And everyone sees if I put 1 and 2 together, I get the right angle. So that's what I need you guys to start being aware of. Those are complementary. And another vocab term, anybody? 1 and 2 are complementary, and they are adjacent, right? Don't assume they're congruent, right? Did I say bisector? Did I put any arc marks on? Nope, so I have no idea. No idea if they're congruent, but they definitely are adjacent. Good. Questions, comments? All right, we got complementary. Now we have supplementary. Adds to 180. Again, two angles only. Two angles only. Elementary school version. There you go. Hi, kids. Look at my two angles. They add to 180. They're supplementary. Not impressed. Here's where you got to be now. Those are supplementary. How do I know they add up to 180? The box told me up here 90. I got that. But now why 180 here?
There's a line.
What about it?
A line is
A
180.
line is 180 degrees. All right, that's how I know 1 and 2 add up to 180. And come on, keep rolling with me. 1 and 2 are also not only supplementary, but adjacent. Good, those are adjacent. Good. And we're going to give them a souped up name in a second. All right, more than adjacent. All right, if two angles are adjacent and supplementary, if they're adjacent and supplementary, we have a new name for them. I don't think you've heard of this term before. They are called linear pairs. Linear pairs. Adjacent angles who form a straight angle. Linear has the word line in it, so two angles that form a line. Linear pairs. Get used to that term. Linear pairs. Two angles that form a straight line. A. Part A. Do you think angles 1 and 2 are linear pairs? Are those two angles that form a straight line? Oh boy. I got some. Anybody? Tim? No, absolutely not. No, they don't form a straight line. How about B? What's B? Are those two adjacent angles that form a straight line? Yeah, so 1 and 2 in part B those are linear pairs. I know I'm throwing a lot of vocab at you. Those are linear pairs. Ooh, how about C? C, linear pairs? What do we think? Are they even adjacent, first of all? Okay, so stop talking, right? Stop thinking. They're not even adjacent to each other because they don't share a common vertex. So these are not linear pairs. Oh, it's so exciting today that you get introduced to your first theorem of the year. It's exciting, Kevin, isn't it? It's all. Okay. This is probably Theorem 1, and I'm not joking around or trying to be funny, but Theorem 1 of 50 for the year. I might be underselling that too. Might be more. First of all, what is it? Like you've heard of Pythagorean theorem before, right? So anytime we write a theorem down, it's a true fact in geometry. That's what you're writing down right now when we say a theorem, a true fact in geometry. And it's about a linear pair. Okay? Anytime I have linear pairs are, and I don't want adjacent because that's kind of the definition of it. We said those were linear pairs, right? We said those were linear pairs. So how do you think, what word am I going to, we already know the vocabulary term. It's not a new one. Linear pairs are, and I don't want adjacent. What do you think I'm going to write there? What do you think, what do we know about linear pairs other than they're adjacent? What's that? They form a line. Keep going. I need more. Okay, they form a line. I'm looking for more vocab. What about the line? It's 180. Keep going. Two angles that add to 180. Linear pairs are supplementary. There you go. There's your first fact. If I have two linear pairs, they are supplementary. Linear pairs are supplementary. There's your first theorem. Wow. Feel like we should take a selfie or something, celebrate your first theorem? No, we're good. Have you guys heard of these before? Vertical angles? Yes, no? Okay, vertical angles. If you have two intersecting lines, they got to be lines. Two intersecting lines, the opposite angles are vertical. Okay, so two lines intersect. Everyone agrees we make 4 angles when 2 lines intersect. The opposite ones are considered vertical. Okay? Opposite ones are considered vertical. So in this diagram here, I have 2 intersecting lines in part A. Would 1 and 2 be considered vertical? No, they're not. Oh, challenge time. But what are they? Use your darn big boy, big girl words here. Let's go, Tim. Thank you. Linear pairs. Good. I don't want a Jason anymore. Tell me they're linear pairs. All right, they're not vertical, but they're linear pairs. How about B? You think those are vertical?
Yeah.
Oh, yeah?
Yeah.
I see some yeah and some no's. Well, they're opposite each other, right? But are they formed by 2 intersecting lines?
No.
That one bad boy is not, I don't think either of them are lines, right? Okay, so that one not vertical as well. And how about C?
Yeah.
Yes, those are vertical. Ready? Theorem about vertical angles. Anybody know any? Well, actually, don't say anything because you guys are going to figure this out on your own with me. Ready? Vertical. Oh, by the way, how about have some self-respect with your spelling, please? All right. How many times I see vertical spelled C-L-E at the end? It's not like barnacle. Okay, vertical. Have some self-respect, kids. Am I going to mark you off? No. Or will I write a comment about being an embarrassment to the math community and maybe your family? Yes, I will. Okay, so have some self-respect. I have to spell this right. Vertical angles are, relax. All right, let me have some moment here to shine, fellas. All right. Maddie, random angle measure, please. Something.
46.
How about 40?
Sure.
Thanks. Good call. That's 40. Find the one next to it. What do you know about these two and the one next to it? They are linear pairs because they're supplementary. They're supplementary. So if that's 40, this will be a $1.40. What about the one next to the 140? That's a linear pair. And the one next to this one? Okay, what do you know about vertical angles? Vertical angles are? Don't use equal. We got a better word now. Congruent. Vertical angles are congruent. Correct. Linear pairs are supplementary. Vertical angles are congruent. Great work. Questions? All right, and then I think you've heard of you definitely have with slope. Perpendicular lines? Yes, no, maybe. Perpendicular lines? Okay, here you go.
I have to go.
Oh, smile big.
Okay.
We'll miss you.
Thanks so much.
Not really.
Okay.
Yeah, bye.
Bye.
Okay, we'll call this line AB. We'll call this line CD. And I'm going to have to throw a little symbol on there. Because perpendicular lines form what type of angles?
Right.
Don't say 90 anymore. Right angles, yes. Perpendicular lines. All right, now you guys know how I do this. I want you to be able to write it mathematically too, that these are perpendicular. Line AB, so everyone write down line AB, right? We know how to do that. Make sure you put the arrows on. Some of you forgot on your quiz. Ooh, symbol for perpendicular. Anybody ever seen it before? No? Come on. Take a guess. Oh boy.
I'm going to guess. Is it 2 lines that are crossing each other?
An X?
Yeah, like both the arrows.
That's an X.
Oh.
Okay, here you go. I'm actually kind of surprised. The upside down T? Oh, yeah, I see. Yeah, okay. Yeah, now you have. Now you have. You didn't know if we wanted to say anything, but now you have, right? And then perpendicular to CD. And there's the perpendicular symbol. And they form right angles. All right? I know, I'm sorry, guys, I'm throwing a lot at you here, but hey, welcome to honors, right? Any issues, linear pair, vertical angles, or perpendicular? We are going to do problems on your own here in a bit. I don't even know what to call that. Drop. All right, you guys ready? I think I'm going to let you guys go on your own here for a couple minutes, see what you can do here on your own. Okay, everyone sees the right angle? It doesn't say, but you guys can assume ABC is a straight line. Okay, it should say that in the directions, but assume ABC is a straight line. Okay, so that's a right angle at angle EBC. So let's find these other angle measures. All right, go ahead. Let's roll, and then we'll do, don't go on to 7. We'll do 7 together. See how much we can get through. Get my cheat sheet out here as well. Okay. All right, let's roll. EBF. I don't need to call on people for this. Hopefully we're good. EBF, what'd you have? 51, yep. EBA? 90. Oh, that was an easy one. DBE.
17.
Look at you guys. Just machines right now. Machines. DBC. Oh, 107. Look at it. Just rifling them off. Well, ABF. Oh, look at you. And then how about DBF? Boom. Any issues? I don't want to spend too much time on that. That would have been bad if I just took a digger right there, huh? How many of you would have definitely just burst out laughing? Because I would have. All right, if I saw somebody do that. Questions? All right, now we're going to get to a little bit harder. I just want to make sure you got this concept of 180 degrees, the right angle down. Now we're going to get a little bit tougher. Two angles are complementary. Let's stop right there. What do I know about them? They add to 90, right? I have two angles, and I don't expect you guys to do this. It just helps me out to show you. I have two angles, angle 1 and angle 2, that add to what? 90 degrees. So there you go. I got to fill in my spots. What's angle 1 going to be? What's angle 2 going to be? The degree measure of the smaller is 50 less than the degree measure of the larger. So right away, we got to figure out, what are we going to call x? Because whatever we call x is going to be used to find either the smaller or the larger one. So I know the degree measure of the smaller angle is 50 less than the degree measure of the larger. So what should we call x, the larger or the smaller? There's not going to be a wrong answer. You want to call it the larger one? You're going to let Tim dictate this? We sure about this? So x equals the larger. All right, so make sure, yes, just like in algebra, I do need a little let statement so I know what's what. Let x equal the larger. All right, so there's x, the larger. What do I call the smaller then?
N.
Two variables? How are you going to solve that one? Let me know when you do. All right, if I called x the larger, I'd probably prefer an x in the smaller as well. And it's the measure of the smaller is 50 less than the measure of the larger. What's up, Kev?
X minus 50.
X minus 50 would be my smaller one. Yep. N. N? Come on. Better than that. Now, I said there was no wrong answer what you call x. Let's say somebody was like, hey, I'll make x the smaller. No problem. What would be the larger one then? X plus 50. Fine. That's fine. All right, no big deal. So here you go. Ready? 2x minus 50 equals 90. Add the 50 over. 2x equals $1.40. X equals 70. I just appreciate it if you answered the question, though. What was I looking for? What was the question looking for? How'd it go? Great?
Awful.
Come on.
No, it's so bad.
What were you looking for in the problem? Larger. What did I call the larger? This is why we have let statements, by the way. It's not, I don't care really about it correcting it. It's really for you. What do we call the larger angle? X, done. And that tells me I don't need to plug anything back in. I already found it because I called X the larger. Everyone's all right? Yes, Matt, go.
The small one is 20. Is not to do x minus 50 and x equals 70.
What are you just showing off? Why do I care about the smaller one?
Because
Just said find, the question said find the degree measure of the larger angle, right? You done showing off? Matt, everyone. Matt. Give it up, Matt. Give it up. Give it up. There you go. Showing off. Showing off. He can subtract. Good job, Matt. Other questions? Anybody else want to throw out a rando fact now before we move on? We're all good? Okay. Ooh, pinwheels. All right. We're going to see a ton of this year. When I tell you numbers are in a ratio. So I have two supplementary angles. What do you got for me? Two supplementary angles. What do you know? Two angles that add to 180. Yep. So again, I'm not expecting you to do this at all. This just helps me show you guys. They're in a ratio of 7 to 2. So here's what it means by a ratio of 7 to 2. Ready? One angle could be 7 degrees. The other angle could be 2 degrees. Is that going to be it, though? That doesn't add to 180. Let's be real. All right, well, we could double them. It could be 14 and 4. That's in a ratio of 7 to 2. Is it going to be that? Oh, let's keep going. It could be 21 and 6. Is it going to be that? All right, I'm already bored. I'm not doing this. I'm not going to keep continuously multiply by 7 and 2 by the same number. But you can find that number using an equation. 7 and 2. We're trying to find what we knew. 1 multiplying it by 1, 2, and 3 doesn't work, right? What you can use the equation for is, what do you have to multiply 7 and 2 by to get 180? See how that worked? All right? Use the equation to find that number. What do I need to multiply by? So anytime you have numbers in a ratio, throw X on them. Okay? Anytime you have numbers in a ratio, throw X's on them, please. All right, ready? So I get 9X, right? Equals $1.80. X turned out to be 20. God, we would have been there for a while, huh? 1, 2, 3, 4, 5, 6. We got to go up to 20. So X that's the 20 we need to multiply by. What's the question asking? Find the degree measure of each angle. Is 20 degrees one of my angles? No, that's what I got to multiply 7 and 2 by. Here you go. So one angle is going to be what? $1.40. 7 times 20, 140. That's where we're getting the 140 from. And then the second angle will be 40. Quick check. Are they supplementary?
yeah.
Okay, quick check. We're good. That's what it means for numbers in a ratio. Multiply by 1, 2, 3, 4. We don't have time for that, though, so that's why I'm going to throw X's on the ratio numbers. And then you guys have one more, correct? On your own. Go. Go. Ooh, read the directions, please, because I give you a pair of congruent angles in this one. I'm giving you a pair of congruent angles. Mark them on your diagram now. All right? Get in that habit. If I give you a pair of congruent angles, mark them on the diagram. And then I have two angles I need you to find the measure of. How we doing? We all right? Okay, so you got 40 degrees was EBC, and I told you the other two angles were congruent. A couple different ways you could set up an equation if you want. If EBC is 40, what's the rest of the angle here? ABE have to be equal to 140, because you know a straight line is 180 degrees, right? And, 140. And if these two are congruent and they add to 140, right? 70 degrees. However you showed that, you know, you could have 2x equals 140. If anybody had x plus 40 equals 180, however you want to show that, you know, I'm pretty flexible there. I just need to see something though. All right, that where you got the 70 from. Okay, all good? Ready to get after it tonight? Yeah, we're not too bad. Okay, we're all good. Compass tomorrow. We're going to be doing a lot more constructions tomorrow. All right, if you take a peek in your notes, all right, a lot more constructions tomorrow. All right, I will see you guys then. Good time today, good time. Compass tomorrow. And then we're basically done with the unit tomorrow. Monday will be review, Tuesday test. Okay, tomorrow's it.